Today's lesson is an introduction to understanding how to dilate points. And after this, we'll go into dilating shapes. But for right now, let's just go to a basic understanding. And to dilate means either to get bigger or to smaller. Similar to your eyes when you get eye drops in them and they make your eyes larger or smaller. Let's take a look at this first problem in Khan Academy. And we're looking, plot the image of point B. Here's B. And it's under a dilation about point P. So it's happening from this. And it's happening at a scale factor of 1/2. So what we're going to be talking about is this distance here. The distance of that blue dot, and where will it be if I have a scale factor? And what it's saying is this distance going to get larger or smaller? And so in the Khan Academy, when you grab that blue dot and pull it away, it'll show a green dot, and we're asking, is this going to go further away or is it going to come closer? And here's how you decide, and it's a scale factor of 1/2, which would then mean smaller. We're going to be getting smaller by 1/2. And the way I'm going to figure out where along here is the halfway point, where exactly is that halfway point? Because that's what they're asking us. This distance half as big. And I think maybe the easiest way is to actually look at the triangle that's made here and what distance we have. From here to here is 6 squares, so half of that would be 3. And from here to here is 4 squares, and so half of that would be 2. So this is what they're looking for. Let's pull this back off the side. What they're wanting you to do is to bring this dot and drag it to here. And that would be your answer. Let's take a look at problem 2. Very similar again. We're plotting point C. Where is this going to move to under a dilation about point P with a factor of 2? So are we getting bigger or smaller in this one? And in this one we're getting larger. We're getting bigger because we're going twice as big. So when I look at this distance between P and C, I have to make this distance from P twice as big, 2. And so if I count those squares, I see this is 5 squares long. And so when you grab this blue dot and drag it, how far do I go? When do I stop? Well, by a factor of 2. And I can go 5 times 2 is 10. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. And that would be the new location. So if I drag this stuff off here, they're wanting you to drag that blue dot over to here. And that would be a dilation about point P with a scale factor of 2. All right, let's take a look at problem 3. In problem 3, they're giving us a coordinate plane now. Here's my point C, the one that they're wanting us to move. Where will this move from? And we're starting at the origin. We're starting at the origin, and our scale factor is going to be 1/2. Is that bigger or is that smaller? And of course, being 1/2, we're going smaller, half the size. So again, you're looking at that distance from that blue dot to your place of dilation, that they're wanting to dilate it from the origin here. That distance there, if you count the squares, is 6. And we're going to do half as big as that. So this, when you move this blue dot and it comes green, half that distance, where is that? Well, that's 6 divided by 2, or half of 6 is 3. And that would be the spot. Again, let's pull this off to the side here. That's would be the answer. That's what the new image with a scale factor of 1/2 is. The last problem, they have a coordinate plane and we're off to the side here. And the dilation, again, is going to be about the origin, which is at 0, 0. So we're talking about that distance from the origin to this point D. And is this distance, when you drag that blue dot, is this distance going to get smaller or larger? And that's a dilation. This is what the dilation is to make that distance smaller or larger, bigger or smaller. And we can see that we're going to go factor of 2. So we'll be making this distance larger or bigger. So now the question is, where are you going to drag that dot to? Obviously it comes along here, this distance twice as big. How do I figure out exactly where that is? And it'll help if I look at the ordered pair. That blue dot is at -3, -2. And what we find is I can just take this scale factor and multiply it by the ordered pairs. So I can take this -3 times 2 and get -6, and the -2 times 2 to get -4, and that's the location of the dot at -6, -4. And that will be a distance that is twice as far. That's what a scale factor of 2 will be. All right, try these on your own, and this is a good introduction for dilations. Thank you.